The topic of today is metadata-driven data warehouse automation. And now Christian said that it's not entirely sure that it was actually Albert Einstein who said this, but for the sake of this presentation, let's say that he did anyway. What he said was that insanity is doing the same thing over and over again and expecting the results to be different. And I agree that is kind of stupid. But what we try to do when we build these data warehouse automation frameworks is that we're actually trying to make something as repeatable as possible again, or as soon as you have something that is a repeatable task, it's actually, wouldn't it be a good idea to actually automate that as far as you can? And you can see this metal worker in the background here. I mean, there's a reason why you build tools like this instead of having a manual saw or something to work with. So I'd like to paraphrase Albert Einstein and say that genius is doing the same thing over and over again and ensuring the results to be the same. So my journey when it comes to data warehouse automation began quite a while ago. It was actually back in 2002 when I was working at a consultant company called Lentus here in Sweden. And together with some other people at the company, we built a data warehouse for a clothing business here in Sweden. It's a nationwide business. So it was, at that point in time anyway, a quite large data warehouse. And this company were quite technically liberated in the sense that we were involved in a lot of open source projects. Some of you may have heard of the database MySQL. That database actually originated within this company, but was later spawned off as its own business entity. So of course we were using MySQL as the primary database for all the data warehouses we built, and we wanted to build something also that were as automated as possible using the tools we had at hand, and MySQL back then was running on Linux servers. So the framework itself was actually written in shell scripting, like the bash born again shell. So we used that as a programming language to actually build this automation framework. And we used this for a couple of data warehouses, and then we decided to actually talk a little bit about this as well. So I think mostly we wanted to come to Orlando because that was a cool place to be. So because the MySQL user conference was there, and actually we had a lot of fun. So we were at that conference and talked about this, which we then entitled Large Volume Data Transformation and Warehousing Using MySQL. And back in 2002, there weren't that many actually at the conference that had actually heard about data warehousing. So yeah, it was sort of a new topic for them. Did we learn any lessons from building this ETL framework? Well, hopefully we did. One of the things that were a big positive when we had this framework was the amount of reusability that we had. So when we started a project with a new data warehouse, we were quickly up and running and could quite easily, instead of having to write a lot of code, we could sort of just configure this framework and have it generate the code for us. So we achieved high reusability thanks to this framework. Also, another big benefit was that once you had figured out how to generate code that did what it was supposed to be doing, it would be a repeatable process, and it would always produce code that did what it was supposed to be doing. So
you can compare that to actually writing code manually or by hand, and immediately understand that it will of course be less error prone over time to use this generated code instead. We also worked quite a bit in this framework with what we back then called separation of concerns. Today we would probably call this layers. So we had different layers in the architecture when we were pushing data. So we had back then also, we actually called it back then also a staging area. So we had a staging area, we had another layer where we had like our key maintenance. So all lookup tables between natural keys and surrogate keys were done in a separate layer. And then we had a normalized layer on top of that, which was actually not the final layer in that case. We also moved further on to a data mart layer, where we sort of just had random model tables, mostly flat tables. It was not dimensional back then. Thanks to this framework, we could shorten the development time. So from start to finish to build a data warehouse was definitely quicker than starting from scratch. We also already back then, and I think this was a really good choice, we decided that we wanted to have a domain-oriented model, and I think we were quite early with that approach. And what I mean by that is it's not source driven or data driven in the sense that you look at the information that you have and build a model from that. Instead, you face the other way around and look at the business, and you build a model based upon what the business is doing, and then you sort of pray for the data to actually be there, so you can populate this model that you have. And when you have a domain-oriented model, this will actually force you to do the work. So you have to do integration work to actually get the data into the model, because the model is what the business is doing, but that's not always what the sources are giving you. Some of the negative things that we discovered was, of course, that writing this in shell script was probably not the best thing, because Bash is not a programming language. Well, not per se anyway, but it was quite hard to maintain over time because the syntax was a little bit contrived. We had this separate layer I mentioned for the key lookups from natural keys to surrogate keys. Having this in a separate layer became actually super fragile, because that meant that you were duplicating the keys in this layer and also in the normalized layer. So they had to be in perfect sync, because if they were not, then you were in deep shit, and we were in deep shit sometimes. So that was sort of a bad idea. And of course, once we started to look at this and see if we could somehow make a product out of this, we quickly realized that there weren't that many companies that were actually using MySQL on Linux for data warehousing. The people that were using data warehousing back then, they were mostly using SQL Server or Teradata. Those were the two ones back then. So that was sort of my story with the first framework. It was, of course, really nice and a great experience to have with you. So a few years later, I started working, a few years after the first framework was built, rather. I started working at a different company called Intellibis, another consultant company here in Sweden. They had already also built a framework for SQL Server, so they had a little bit of substance in that area. But when I came there, I had with me the ideas from the framework that I had built. So I, together with some colleagues there, decided to do a version 2.0 of that framework that they had, incorporating many of the ideas that I brought with me. Given that we realized that, or I had realized anyway, that Bash was not the greatest programming language, and we were now in the Microsoft environment, we could pick something else. And somewhere in between the two there, I had sort of fallen a little bit in love with something called XML and XSLT. I'm sure you're familiar with XML, maybe not XSLT. XSLT is a transformation language that you can use if you want to transform XML to another XML document, or if you want to transform XML to text or SQL code. So that seemed like a pretty good choice at the time anyway. So we picked that. We had our metadata definitions written in XML, and we used XSLT to produce SQL code from this XML metadata. And then we of course needed something that could sort of drive the whole thing. We're going to look a little bit about look more at on that later. You need some sort of workflow, of course, when you have a setup like this, because what it boils down to is some jobs that will be pushing data through your sort of pipeline that you have, or a frame. And there will be different stops where the data rests in between. But to push this around, we actually decided to use integration services, which is sort of like Microsoft's response to, and at that time it was Informatica and IBM Data Stage, those types of tools. And we also built a few things in .NET code at the time. So you can actually see here on the images here, the code on the left. On the left is the XML definition, the metadata definition. The command prompt up on the right is where we actually are running the framework. And the bottom right is an HTML report that actually shows you all the steps, all of those stops that the integration services were driving. So those are all the job steps, and you could actually click on them and see all the output and everything. So quite a nice report, actually. It was easy to follow. So this became sort of a product. We productified this a little bit at Intellibis. So when we approached a new customer, we said that we are going to bring in this fantastic framework that we have. So you're going to have to pay us like a startup fee. Amazingly, you could do that back then. So businesses here in Sweden, they actually paid us money before we actually had done even a single hour of work, just because we came with this framework. And this became quite popular. So I think somewhere around at least 20 different companies here in Sweden were running this at the time. And it was working quite well. At one company, one insurance company, we even they decided to outsource their IT department to India. So I was working a lot with Indian people and teaching them the framework. So, and I have this sneaking suspicion that they actually stole it at some point and began using it themselves, because we started to get questions that were not related anymore to the things they were doing for that insurance company, which was kind of weird. Anyway, did we learn anything from this? Yes, we did. One of the things that we didn't have in the first framework, but we had in this one, was actually to have logging. you saw that HTML report where you could actually click around and see how each job had been run and if it was successful or not, and the output. That was great, actually. You need to be able to have a grasp of what is happening. So logging is mandatory, definitely, when you're building a framework. There's some background noise now, but not from me. And another thing that we realized when we were working with this was that XML is actually a really great language for expressing configurations or the actual metadata that will drive your automation, because it's an extensible language. You can easily produce hierarchies. It's quite easy to it's quite human readable as well, so it's quite easy to understand a configuration that is written in XML. Another benefit of this framework was that, of course, this was much easier to actually sell as a product, because there were a lot of companies that were using the Microsoft stack, and we were focusing on that. So that was good. And those separated concerns I was talking about earlier, like having different layers today, like a staging area, normalized area, transformations and stuff going on in between. Workflows are the thing that actually glue these separated concerns together, that actually keeps these jobs running in the order that they should be running. In this case, we could actually run lots of parallel jobs within integration services. And that was like, it was terrible to get that code to actually run well, but once it did, it worked rather good. We took another approach in the next framework though, because it was quite difficult. This framework also had a lot of BAT files. I don't even know what BAT stands for. BAT files. It's the thing that you can program Microsoft DOS with. And if Bash was not meant for programming, then the BAT files are absolutely, definitely not meant for programming. It's extremely limited in what you can do, and it's even simple things become terribly contrived. So that was a bad choice to try to use them. XSLT, that I really liked, turned out to be a maintenance nightmare, mainly because the language itself is actually, it's quite verbose. So to actually see or get an overview of what the code is doing, you have to sort of scroll through several pages just to understand something, which meant that every time you came back to one of these XSLT files and wanted to do something, add features or fix a bug, you had to spend like an hour or so just figuring out how the heck it worked. So that turned out to be a pretty poor choice, actually, even if it's very powerful. And like I said, we did a few things in .NET. Plugging that into integration services was also a little bit of a nightmare. And those little pieces of .NET code became sort of black boxes. They were hard to find even in the integration services packages. So that also was not such a good idea. Then some years later, I actually stayed at Intellibis for about 5 or 6 years, I think. And after that, I actually started my own company. And at that time, I think we were in 2014. You can actually see the first release date actually on this page, where I released the third version or the third framework. Because what had happened was that I left the company, started my own company, and I had been working in my own company for a couple of years. And I think around 2012 it was actually, or maybe a year after, when SQL Server 2012 was being installed in different places.
these companies that were using the old framework from Intellibis, they contacted Intellibis and said, now we're going to upgrade our SQL servers. Is your framework compatible? And it was not, because there were a few things that you had to do in order to get it to run. You had to recompile stuff and things like that. But there was no one actually left at this company that could that had worked with this framework. So basically, they were just sitting around on the intellectual property and had no competence to actually sell or do consultant work concerning the framework. So I talked to them and said, maybe you could release the intellectual property and let me help these companies get it up and running in Microsoft SQL Server 2012. But they said that they did not want to release the intellectual property. So fine, I thought. So I let them keep it and decided to actually write the third ETL framework based on all of the experiences and lessons learned from the previous two. And I was fortunate enough to have one company here in Sweden. It's Terracom. It's a company that owns all the broadcasting equipment for terrestrial television and radio here in Sweden. And they also maintain the network for emergency personnel that they use when they are communicating. They were sitting on the old framework and needed to upgrade to the new. And they were kind enough to sort of sponsor the work on this one. I had one requirement though, and that was that, and they understood, because neither of us wanted to end up in a situation again where someone was sitting on the intellectual property. So my requirement was that if we're going to do we're going to do it as open source, and they agreed upon that. So the final, maybe not the final, hopefully, but anyway, the third framework now is open source, thanks to that, and it's available on GitHub, and it's been around for a while. The first version, like I said, was in 2014. We're still actively developing this framework, and it's maybe not as widespread as the framework, the one from Intellibis. I think I know about 10 companies using this framework. So it's definitely not something that is all over the place, but still. I think also today the presentation, it will be a lot about the lessons learned and the things you should keep in mind when you work with data warehouse automation, and not particularly trying to sell this automation framework, even though I believe this is quite a good framework. One of the things, anyway, we did here was to leave that XSLT coding behind us. And we decided instead to use a templating language. Today there are quite a few templating languages, like mustaches and handlebars, have all these cool names. Back when we were building these, there weren't that many, and as it happened, we had already developed a templating language for another purpose, because somewhere in between here, I had been involved in the development of anchor modeling, and we developed an online tool, and we also generate a lot of SQL code in that when we build our data warehouse models. And to do that, we invented a language, templating language called Sisula. It stands for Simple Substitution Language, and it's a very generic way of doing templating. You define sort of a template syntax, and you provide what we call a configuration object, and you can then intermix this with some target language, and in our case it's JavaScript, could be something else.
So Sysula in itself is a super generic templating language, but we use it now with XML and JavaScript. And basically how it works is that it takes this XML, converts the XML to a JavaScript object that you have access to, and then it's a lot of like all templating languages, the code itself looks a lot like the result that you want. So I can show you later, but it looks very much like SQL code with some variable substitution going on. And what happens internally is that it uses regular expressions to actually transform all of that to JavaScript in the end. That is then parsed and evaluated. So this was back in September 2020. We were at 1.15.2. That was when I did the first version of this presentation. I think we're now at 1.16.1, if I remember correctly. There's also some YouTube videos. So if you visit this GitHub page, you can find a playlist where you can actually watch tutorials on how to use this framework, if you're interested. So what lessons learned have we got now from having been running this in production at a few companies now for quite a few years? Well, one of the good things, one of the really good decisions we made were this open source philosophy, because that absolutely ensures longevity. Even if I should for some reason decide to stop developing this, they can still use the framework and continue to develop it if they like. The templating language was also a great choice, because if the XSLT was very verbose and hard to understand, the templating languages, they look very much like the end result. So it increases readability, which also makes it easy to extend if you want to. I've also noticed that portability to other stacks, even if this framework is very much focused on Microsoft SQL Server still, we built this with portability in mind. So we sort of built it around generic automation principles that should make it possible to actually port this to other stacks if you want to. But right now it's very much geared towards SQL Server, but I can see myself porting it to some other interesting databases in the future, particularly if some projects would pop up. JavaScript is also a great language, because lots of people actually know JavaScript, so that makes it easier to actually find people who want to get involved in the development of this framework and can help out. We also decided that rather than like we had in the old framework, that maybe you had to rely on some third-party components or actually compile stuff and do stuff like that, we tried to leave that behind, and for this framework there's actually no installation required. And this helps a lot, because many companies today, they have outsourced their IT. And it's always difficult if you come there and say that, well, in order to run this framework, you first have to install this software 1, 2, and 3 on your servers, and then you're going to have to wait a couple of weeks before the outsourced people actually start to recognize and do things. So you are completely removed of that lag, and it's very easy to... Oh, cars in the background. So it's very easy to work with that. Some of the things that I haven't been doing is actually market this very well. Mostly, yeah, I've had too much other things to do, basically. But if you're going to have a successful framework that you actually want people to use, I think I should have actually tried to market this better. And today there's also lots of alternatives when it comes to frameworks. And I believe some of them are probably really great frameworks also. So maybe and hopefully we can learn from each other and coexist peacefully. And of course, some people do not like to use frameworks at all because they want to reinvent the wheel every time. Why? Well, like I said, having a framework like this actually saves time. So if you're a large consultant company, for example, maybe you don't want to save time, you want to spend time instead, because time is what actually gives you higher invoices. So yeah, it's not always like, perhaps there's different agendas when it comes to actually working with automation out there. At least that's what I've seen. So this framework then, what is it? Well, it's available on GitHub. So if you go there, you will find a page that looks pretty much like this, where you can actually see all the code. And under releases, you can actually find the different releases. You should, if you're going to use this, you should be using the releases, not download something from the green code button, because then you will be downloading the development version. Could be good to know. Even though we always try to only check in thing that works, but sometimes you make mistakes and introduce bugs. Happens. We also built some, and this could be of interest even if you're not deciding to use this framework. If you are in an environment where you're using SQL Server, we actually realized there were a few features that we really missed. So we decided to write these using something CLR, which is again, of course, .NET code, but this integrates quite nicely into SQL Server. So you can actually add features yourself to SQL Server that it's missing. Like, for example, regular expressions. It's insane that it doesn't have support for that. So we have some intelligent support for regular expressions added into this one. Or like simple things like conversion between local time and universal time. You don't get that within SQL Server using the built-in features for some reasons either. So there's some great utilities in this little utility package. Could be worth checking out. So how does this framework work then? Well, like I said, we try to build it on some generic principles. And our generic principles look like this, and this is very much the way most of these frameworks that are built have been working. We most of the time work with sources that are either databases or files. If they are files, we're not going to trust anything, so we're going to read them as raw files. So we will actually just read row by row what's in the file into a table in the staging area. If it's databases that we're fetching from, we're actually we're gonna trust them a little bit more. So in that case, we're gonna believe that the data types that they have said that they have in their tables are actually what's in those columns as well. So we can immediately actually pull that data into typed tables into the staging area where columns already exist. Whereas in the raw part of the staging area, there are no columns. It's just one column containing the entire row of the file. So to get from this raw form to the typed form, we have two steps. We call it splitting and checking. Splitting is actually splitting the row into columns, and checking is actually looking at the data types and ensuring that the types correspond to what are in the typed tables. So we have some intelligent error handling in case where this doesn't work. The good thing about this is that the files that we read into the raw area, they can look pretty much like anything. So even if you have like long headers that deviate from the actual format of what you want to read, that's no issue. You can just work with that anyway. So it can be very irregular information. It can be JSON, XML, CSV files, or anything, or any combination within the same file of all of the things as well, as long as there's some way using regular expressions to tell it apart. Once we have the typed data that have passed through these quality checks, we have a step that we call baking, and this is basically just a fun word for the transformation logic that you do to either transform the data into some formats that you need. Maybe the gender are just M and F and you want to have male and female, or it could be integration logic where you actually have to look up in order to figure out if you've seen something before or not. Maybe you have to pull out stuff from various parts of your model. So this is what baking is about. But once you have baked your data into the form that it needs in order to actually enter the model that you have, you do the mapping. So you map this baked data to your target model that you have. So in the target there will be entities with columns into which you want to put this baked data. That's where you sort of get to your data warehouse level. And finally, we have another actual step after the data has been loaded into the model, which is the calculating step. And this could be one of the things that we often use this for, is to actually do logical deletes of data. So the data that for some reason was no longer available in the source, or that had been marked as deleted or whatever, could be there. It could also be that you create some sort of new information that were not in the original information, like a customer classification based on something that you want to keep in your model, like bonus levels, gold, silver, bronze, stuff like that goes on in that calculating step as well. So it's very much an ELT framework, because you, as quickly as possible, get the extracted data into the database. Then you start your baking, then you have a little bit more of the loading when you put it into this model, the target model, and then you end up with a little bit of T at the end again. And of course, down at the bottom, you have some sort of workflow that actually puts all of this work together into a step-by-step fashion. So looking at it, we kept the XML format. So the source specification looks like this. I'm not going to go into much detail about this, but here we have the splitting information that helps you with the splitting. So you tell it which delimiters it's using, how the fields are terminated, how the rows are terminated. There are checking stuff, so you can check keys, for example, that there's in primary key integrity within the data that you're loading, that it has this fits into a varchar 555. When it comes to the target specification, this is also XML. So here we define targets and loads. And in a separate load, you have this baking step, which is indicated by the SQL code before. Then you have the mapping, which maps a source, and that from the source that's a column in the baked data, to target, which is a column in the data warehouse. And you also see there's this designation of the map with something called as. So there's different types of maps. In this case, the mapping is a natural key that will actually help the generator generate the correct types of joins when it produces the final code. So there are a number of different types of maps you can use. And then afterwards, I said you have this calculating step, which is just SQL code that you can put in this after section. So it's quite simple, actually, in how it's defined. And of course, we have to put all this together then in some sort of workflow, and you define a workflow also in XML, where you can define variables. You may have seen here that there's some stuff that has like a % sign and a variable name and a % sign. Those are actually variables that you have either defined here in the XML code, or they are environment variables. If we have time, I will actually show you a little bit about that too. So the workflows you can actually build any way you want. We have this convention where we have a staging workflow, and that's responsible for the splitting and checking part. Then we have a loading workflow as well. That's where the baking, mapping, and calculating goes on. And usually you have these set up so that once the staging job has finished, the loading job starts immediately after. It's quite good to have that separation, because it's not that uncommon when you do development that you want to stage once and then you work on your loading procedures, so you do the loading maybe 10 times before you're satisfied. It would be cumbersome to actually have to do the staging all over again between those steps. So a project here, we also try to keep this simple. A project is just a folder that you have that has a certain structure. In this folder, you will actually see one of the files is that I mentioned, the variables, where you can actually set some environment variables. So these can be reused within the code. So basically, when you see this job name here, where it says system source loading, the system and source there with the % signs, they will actually be replaced by the system and source that you see here. So it will be PGA and Kaggle, and you have target database, target schema, and this makes it quite easy actually to switch between different types of servers that you have. Many of you probably work with a development server, a test server, and a production server. And usually the only thing that differs for us between those is this variables.bat. Or if for some reason you want to change the names of anything, it's quite easy to just change it there. I also mentioned we try to use zero third-party programs to actually work with this. So everything is set up by, so in order to actually generate all the code, you're using something called syssolate, which is a command. It's built using PowerShell and something called HTA, and both of these are built into all modern versions of the Microsoft Windows operating system and server versions also. HTA is HTML for applications. So that also means that it's JavaScript that's used. So when you run this syssolate on something, you actually point out the folder that contains your project, and you follow it at the end with, if you want to install something, you follow it by the server onto which you want to install this. And of course, another principle that we have is that installations should be repeatable and safely repeatable, so you can do this as many times as you want without actually destroying something or generating lots of duplicate code or anything. When you run this, it will generate a lot of stored procedures for you. You can see them on the left, even if it's a little bit blurry. What these procedures have, normally it's a lot more than this. This is just a simple example. But at the beginning of this procedure is some calls to something in a metadata structure. You can see it says there golf DV metadata work starting right to the left of the green text. And that actually stores metadata information about this job. Like I said earlier, logging is mandatory, and this will actually log when this stored procedure is starting, along with a number of other things. So this framework comes with a predefined metadata model. So even if you were to use this framework for something else than anchor modeling, the metadata model is an anchor model, so you'll have to live with that. But the things we store there are stuff like who did what when, did the job go as planned, what stuff did you affect when you ran this, how many operations were performed, and also we can actually tell from where it got the idea to do such a weird thing, because we actually store also in the metadata the actual configuration. So all the XML files that you saw, they will actually be put into the database here as well. Then, of course, later on in these stored procedures, there's the actual loading magic that populates the target database or data warehouse. And it actually all boils down in the end to merge statements. And depending on those mappings, some of the things will be in the on clause, like if there's a surrogate key or a natural key, that will actually be the join that you're using. And then it's just simple merge logic. So if it's not matched, that means it's something you haven't seen before. So then you need to insert the information. If it's something you have seen before, then you need to do some sort of intelligent updates instead. Another thing that we built, and this was actually something that came all the way from the first framework, something we built a little bit later there, was a statistics model. And we also have this in this framework. And the statistics model, it helps you with keeping track of how your data warehouse is growing over time. So it will actually gather statistics on every object, every table that you have in your database, and check how quickly it's growing, both in megabytes and number of rows. And once you've done this a few times, it actually has some built-in statistics that will determine whether this growth is within normal range or if it's trending in some direction, if it's in sync or if it hasn't been loaded in a long time, stuff like that. So it's a great way to actually find stuff that deviates from the normal. So hopefully I will have time for a little quick demo. So I'm going to try to switch to remote desktop because I'm on a Mac. Anything happening? There. And Microsoft SQL Server doesn't run that well on a Mac.
Actually, you've almost used up your time, but I think nobody will be angry if you do a quick demo.
No, I know it's your fault. You took too much time in the beginning with your stuff.
Yeah.
So yeah, I'm going to keep it short. So here's some sample data that we have. It's in the incoming folder of the golf example that comes with the framework. This is what the data looks like. It's information about golfers, and there's some different statistics about each golfer. So it's like driving distances and putting averages and stuff like that. And there's a date also from when this was. So it's kind of nice data because it's historized also. So right now I have absolutely nothing in my database. So the first thing I'm going to do is to create a golf stage database. It will be our staging area. And I'm also going to create a golf data warehouse like that. The first thing I need to do quickly is to install, where's the metadata now? I need to get out there. Metadata. I'm going to install the metadata in my golf data warehouse, the metadata model. So when I run a job, it can actually store the metadata, otherwise it will just crash. So quickly doing stuff here, as you can see. So with this, there's some utility stuff, of course. Lots of stuff that I haven't mentioned today. So now my staging area is prepped. My data warehouse area is prepped. I can keep the metadata somewhere else in a separate database if I want to. There are no jobs currently. So right now I'm going to run this syslate with my server. So what happened now, it read all the XML files, generated SQL code, installed the SQL code, created jobs in the job server agent. So if I do a refresh there, you're going to see it has some staging and loading job. And if I go to my Golf stage, there will be some stored procedures here that these workflows or these jobs will actually be calling now. So if I start the staging job like this, it disappears. Nope. There it is. A staging job completed. So, oops. I don't know what happened. Maybe if I do this here. So in here, I now have tables. Like that split table I was talking about, the end table was the type one. So if I look there, I have my data here that was in that file. So here it is again, player name, date, statistics, the variable, the value, with some other information here. I'm not going to go into details about that right now either, but good to have. So the next job was actually the loading job. So I'm going to start that as well. Oops, I can't do that because I don't have a target. I don't have a model yet in my data warehouse. The data warehouse is just having the, it only has the metadata model right now. So here's the data warehouse model, Golf data warehouse, and switch to the Golf data warehouse database, execute. Now I have an anchor modeled data warehouse with Golf data here, but not populated yet. So I'm going to run that job, start job at step, and boom, there it is. Now I have a loaded data warehouse. Not huge in any means, lots of tables because it's an anchor model, but in the views I will have like the latest player here. So let's check it out. Latest view for player data. And as you can see, I have all my players here. In the statistics, I have all my statistics. It's only driving distances. But if you want to, you can download more data from Kaggle. This is open data that you can actually use. So that was a very quick, super quick demo. But have you ever seen anyone build a data warehouse faster than that? So let's see, how do I get back now? Let's just switch this off and go back here. And now I'm going to do my final slide for the evening. And I promised also to say a word of warning, and this is my word of warning. Some features in this framework are missing, but I'd like to say that they are deliberately omitted, because the usefulness of your data warehouse is proportional to the effort you put into these features. My fear is seeing some of the tools and stuff that are on the market that claim to do data warehouses for you with just a few mouse clicks. They are not proper data warehousing. That's not proper data warehousing. They are just a replacement for what you could do, like with some analytical tool like Tableau or something, where you just import or suck in some data without thinking much about it. So I'd like to say that there are actually no click solutions to proper data warehousing, and that's my word of warning. If you tread down that path, please be aware of what you're doing.